Everyone listen. Lexical analyzer first, syntax analyzer next, semantic analyzer next, intermediate code generator next, code optimization is next, target code generator is next. These are 6 phases of compiler or 6 functions of compiler. Lexical, syntax, semantic, intermediate code generator, code optimization, target code generator. Now remember everyone know, everyone having some functionality. So if anyone asks you what lexical will do, it will do tokens. What syntax will do, it will create the parse tree. What semantic will do, it will do something related to type checking, like undeclared variable, multiple declaration, right? Something like that. Intermediate code generator, it will create intermediate code. Code optimization, if any optimization is possible, it will do. Next one, target code generator. So it will convert whatever code is available. And after code optimization is over, whatever code is available, it will convert it into target code generation, means final requirement. It will convert into final goal. Everyone know this, right? Everyone know. Now observe clearly here. Listen, observe here. Careful everyone. Lexical analyzer to intermediate code generator. This is called front end of the compiler. This is called front end of the compiler. This is called front end of the compiler. Only last phase of the compiler, which is called back end of the compiler. It is called back end of the compiler. Lexical to intermediate code generation is called front end of the compiler. Target code generator is known as the back end of the compiler. Remember, code optimization is optional phase of the compiler. It is an optional phase of the compiler. Means, right? Sometimes code optimization may not be possible. Some people are saying that, sir, why code optimization not possible? While doing intermediate code itself, you may do code optimization. While doing intermediate code itself, you may do code optimization. Means whenever I am writing intermediate code, I may be careful. I may write the code optimization. Means optimized code I may create. It is something like this one. When you are creating a minimal DFA, one way is create DFA, do minimization. That is the one way. What some people will do is, sometimes they may create the minimal DFA directly. Right? Sometimes, if possible by me, I may create minimal DFA directly. Sometimes, if I have doubt, I will create DFA. Afterwards, I will do minimization algorithm. So what I mean to say is, while writing intermediate code itself, if I am careful, there is no need of code optimization. Suppose if I have doubt, I will write intermediate code, then afterwards code optimization I will apply. Code optimization is optional phase of the compiler. Lexical to intermediate code is the front end of the compiler. Target code generation is the back end of the compiler. So this is also called as only this if you take. Right? In some books I see this is only this if you see. This is the middle end of the compiler, not front end, back end. It is the middle end of the compiler. It is the middle end of the compiler. It is the middle end of the compiler. So they will ask you in the examination. In the examination, they will ask you, which is the middle end of the compiler, code optimization. Which is the optional phase of the compiler, code optimization. Who are the part of the front end, lexical to intermediate code? Who is the part of the back end, target code generation? Target code generation. I hope everyone is comfortable. Some people are asking, your goal is low level, your goal is high level to low level. Your goal is high level to low level. Why are you doing intermediate code? It is always better, go slowly. If you want to go from right side to left side, don't go directly. And those people who are watching, right? See, those people who are watching this class, can you help me, right? On national highway, when the accidents will happen, can anyone guess? You may see on the national highway, some accidents are going on. Can anyone guess, whoever watching this class, why those accidents are happening? Can anyone help me? On national highway, you may see in the newspaper or you may see in the TV channels, some accidents are happening. What will be the reason? What will be the reason on the national highway? One reason is fast. One reason is fast, that is okay. One more reason is fast, listen, fast left turn, fast right turn. If you go immediately left, immediately right, problem will come. There are some people who are crossing, who are going from right to left immediately. Right to left, they are going immediately. Left to right, they are going immediately. You cannot do like that in life also. You remember, you cannot go right one place to another place directly. Go slowly. Go slowly. Right? Don't jump here and there. If you jump here and there, problems will come. Left to right, you are going directly. Left to right, if you want to go via middle. Don't go left to right directly. Left to middle to right. So high level to low level, go via middle level. Go via middle level. Please careful. Someone is saying sleeping. Yeah, directly going left to right. See, sudden turns in life also, sudden turns if you do, problems will come. Please observe, whoever listening this class, don't do anything blindly. Don't take any turn blindly. I don't like gate, I will write cat. It's not like that. If you don't like gate, take some time. What exactly you want to do that. Don't take blindly. Right? Don't take blindly. If you do blind turns, it will give a lot of bad things. It will spoil your life. Right? So please careful. That's what I want to say from this diagram. Right? High level to low level, go via middle level. Front end, back end. So from now onwards, if anyone asks you what is the front end of the compiler, lexical to intermediate code. What is the back end target code? What is the middle end code optimization? What is the optional phase of the compiler code optimization? Okay, fine. That is fine. Now listen. Everyone listen. Everyone listen. See this correctly. If you see the intermediate code, you will find out like this. See this one. If you see intermediate code, you will see like this one. T1 is equal to A plus B. T1 is equal to A plus B. T2 is equal to T1 star C. Something like that. Intermediate code, if you see, T1 is equal to A plus B. T2 is equal to T1 into C. But if you see the target code, you will see mul R1, R2, or maybe add. If you want, you can keep add. First add R3, R4, something like this. Right? Target code contains something like this. Intermediate code contains something like this. So can you help me? Front end and back end. Who will give machine dependent code? Front end and back end. Who will give machine dependent code? Whenever you are doing compiler, whenever you are doing compilation, front end followed by back end. Okay. Front end, back end, who will give machine dependent code? Front end, back end, who will give machine dependent code? So remember, these are the machine instructions. Machine means processor. These are processor instructions. Remember, it is going to be machine dependent code. It is a machine dependent code. Remember, it is a machine independent code. Front end of the compiler will give machine independent code. Back end of the compiler will give machine dependent code. Someone is saying that, sir, can I ask one general doubt related to college admission? So can you ask us? Can you WhatsApp me? It is a seriously one class is going on. Seriously, one class is going on. Can you ask me? If you have our WhatsApp number? Can you ask me? This is our WhatsApp number. You can ask me. Yeah, fine, perfect, perfect. Come here now. So front end of the compiler will produce machine independent code. Back end of the compiler will produce machine dependent code. Right? I think until now everyone is comfortable. Now see this. Now see this. Everyone listen. Everyone listen. Everyone listen. If I do careful, if I do, what is the meaning of machine dependent code is? Machine dependent code means, listen, machine dependent code means in which machine, in which computer, careful everyone, machine dependent code means in which computer you done the compilation, in which computer you done the compilation, right? The final answer, whatever is coming is that processor, that computer contain which processor, those processor instructions you will see. Machine dependent code means in which computer you done the compilation, that computer contain which processor, that processor instruction set will come. Every processor having instruction set. P4, Pentium 4 processor having one instruction set. Intel 7, i7 having one more instruction set. One processor to another processor, instruction set, right? Instruction set is keep on changing. Right? Sometimes, right? One processor instruction set is smaller, which is also called as RISC, reduced instruction set computer. Right? Some processors instruction set is bigger. Complex instruction set computer, Cisco, RISC and Cisco. Like that. What I mean to say is, in which everyone listen, in which computer you done the compilation, that computer contain which processor, that instruction set will come. That is the reason it is called machine dependent code. Machine dependent code. Now come to one small story here. Come to one small story. If you do Java compilation, listen, if you do Java compilation, everyone observe. If you do Java compilation, lexical analyzer will execute. Lexical analyzer, right? Whenever you do Java program compilation, lexical analyzer, right? First complete. Syntax will complete. Semantic also will complete. Intermediate code generation also will complete. Remember, Java compilation until here. Right? Java compilation until here. Supposition that in some computer, Java program you compile. When you do Java compilation don't produce low-level code. Java compilation will produce intermediate code, which is also called as machine-independent code. Java compilation will produce machine-independent code. It is a Java program, right? Java program, if you do Java compilation, you don't get the machine-dependent code. You will get the machine-independent code because until here it will be done. Now on this one, right? On this machine-independent code, right? If you do runtime, on this code optimization will be done. Afterwards, target code generation will be done. Afterwards, running will be done. This is the way, right? Java program running will be done. When you say running time, the story will be done. When you say run, remaining story will be done. Java compilation will produce machine-independent code. But when you say Java program running, then remaining story will be executed. Code optimization will be done. Target code will be done. Next one is lastly running will be done. But if you see the C program, if you see the C compilation, lexical analyzer will be done. Syntax analyzer will be done. Semantic analyzer will be done. Intermediate code generation will be done. Next one is going to be, right? Code optimization will be done. Next one is target code generation will be done. This is the C program. This is the C program. C program, right? So supposedly in some computer, C program you compiled. The output, whatever you will get is the machine dependent code. Machine dependent code you will get. The interesting thing is C program, in which computer you done the compilation. In that computer only you can run. In the same kind of system, in the same kind of processor only you can run. You cannot run in some other system. In the same system you have to run. So that is the meaning of machine dependent code. The meaning of machine dependent code is, right, that instruction set whichever is coming, only that system can understand. Other systems may not understand. So C program, if you compile, you will get the machine dependent code. That means in that system only you have to run. C program you cannot compile in one system, you cannot run in another system. But in the case of Java program, you can compile in one system, in another computer you can run. You can run in another system. Right? Computer C1 you run the compilation, computer C2 you can do running, computer C3 you can do running, computer C4 you can do running, computer C5 you can do running. That's the meaning of machine independent code. But in the case of the C programming, right, computer C1 you run the compilation, right, computer C1 only how to run. That is the meaning of machine dependent code. So the advantage with the Java program is in one computer you can do compilation, in another computer you can run. But in the case of the C programming, in which computer you done the compilation, in the same computer you have to do run. So that is the advantage with the Java programming is, right, portability. Portability means right, in one system you can compile, in another system you can run. Java program having this capability, that is portability. That is portability. Right? In one system compiling, in another system running. But in the case of the C programming, in one computer you can compile, in another computer you can run. No, same computer you have to run. Someone is saying how online compiler runs. How online compiler, maybe they are doing for user convenience. For user convenience, they may be doing everything by themselves. Right? They may be doing everything by themselves. User convenience is important, so they may be doing everything by themselves. With one click, maybe many things are happening. Is it okay? So here no portability. Because machine dependent code. Whenever machine independent code, portability will come. Someone is saying virtual machine, right? Portability, another name is virtual machine. Means in one system you can run, one system you can compile, in another system you can run. Now, one more important question I want to ask everyone. Java compilation will give high level or low level or right, intermediate code. Java compilation will give high level or low level or intermediate code. Java compilation will give high level or low level or intermediate code. Intermediate code. That is the reason Java got the capability of portability. That is the reason Java got the capability of portability. Right? I hope everyone is fine. So Java program compilation output is going to machine independent code, which is also called as right. Right, intermediate code you can say, machine independent code you can say. Right, the advantage is in the different system you can run. The problem with the C compiler is it will give machine dependent code. In the same kind of system only you can run. Right, please take care. Now it's an interesting question. Everyone observe. It is an interesting question. C compilation, Java compilation. Which one is taking more time? C compilation, Java compilation. Which is taking more time? C compilation, Java compilation. Which will take more time? Go ahead. C compilation, Java compilation. Which will take more time? C compilation, Java compilation, which will take more time? C compilation, because when you say C compilation, this much should be done. 6 people should run. When I say C compilation, 6 pages should run. But when you say Java compilation, only 4 pages. So C, right? Java compilation will take less time, but C compilation will take more time. Java compilation will take less time. C compilation will take more time, because C compilation means 6 people should run. Java compilation means only 4 people should run. Next one. C program running, Java program running. C program running, Java program running. Can you say which will take more time? C program running, Java program running, which will take more time. C program running, Java program running, which will take more time. C program running, Java program running, which is taking more time. Yeah. In the case of the Java program running, in the program, when you say Java program running, then it will go to code optimization, then it will go to target code generation, lastly running. So in the remaining phases of the compilation will be done. So left out compilation plus running. Left out compilation plus running. But if you go to the C program compilation, see, C program compilation already done, directly running only. So C program running will take less time. Java program running will take more time because little more, right? Little more compilation left out. Java program compilation will take less time, running will be more. But C programming compilation more, running will be less because C program running means directly running. But Java program running means left out compilation plus running. So please take care. Please, everything is important. Everything. As a computer science student, you should take care about what is compilation. In the compilation, how many people will participate? In every compiler is similar way. Or different compiler, different, right? Different compiler, different. The person who invented the programming, he will decide everything. What to keep in the front end, what to keep in the back end, everything he will decide. The person who created the programming language, he will decide what kind of compiler he is expecting because he only will create. See, writing programming language is not a big deal. Writing compiler is a big deal. When he is writing compiler, he will decide what to keep inside, what to keep at the time of compiler, what to keep at the time of running. He will decide everything. So please take care everything. They may ask you what, right? Who are part of front end? Who are part of back end? What is the middle end? What is the optional phase? Next one. Java compilation. Java compilation is a full compilation or half compilation. What is the advantage you will get? If you do half compilation, what advantage you will get? If you do half compilation, you will get portability. What is the side effect? Running time is more, compile time is less. If you do full compilation, what is the advantage? Directly you can run. Running time is less, but compile time is more. Everything having some advantage, some drawback. Everything, you cannot get all advantages only. You cannot get all drawbacks only. Everything having some positive, some negative. Yeah, please write down. Everything, whatever you feel, every point is required. Through experience, everything, whatever I am teaching, somewhere in one of the previous paper it is there. See, in the previous paper it is not there, I don't teach. Because as I mentioned to you, compiler book contains 1500 pages. Compiler book contains 1500 pages. If I don't have experience, I will teach every page. Every page I will teach. Because of I have experience, whichever needed, those only I will say. Whichever needed, those only I will say. I can say what is there, right? Reading and saying what is so great in that. I can read all 1500 pages. I will say everything as it is. But the number of marks which are coming is 6 marks. Why you study 1500 pages? What is needed for the examination? Please study that. So I don't say unnecessarily more. Whatever necessary, I will keep in your notes. Yeah, I hope everything is fine. If you okay, I can go to the next one. Full compilation, C language, half compilation, Java. Advantage with the half compilation, less compile time. Drawback, more running time. Full compilation advantage, right? Running time less, but compile time means more, right? Perfect. If you okay, I can move to the next one. Now, if you okay, I can move to the next one. Can you see this also? Everyone observe. Can you see this also? One more interesting story is there. Can you observe this also? Richa is saying, good evening, son. Good evening, Richa. Someone is saying, class fee is too much. Okay, fine. Thank you. Thank you so much. Thanks for your feedback. Right? So there is a 25% discount. You can use it. Right? 25% discount is there. Right? If possible, you can utilize it. Right? Thank you so much for your feedback. Now class is going on. Thanks for you. Thanks for you. So now can you come to the next one? Can you come to the next one? Everyone listen. Everyone listen. Everyone listen. One important point is coming. Everyone listen. See this? See correctly? Whenever you say compile, whenever you say program is compiling, remember program compiling means these all people, see, these all people having code. Lexical analyzer having, right, 2 lakh lines of code. Syntax analyzer is having 5 lakh lines of code. Next one, semantic analyzer is having, right, 2 more lakhs of code. 2 more lakhs of code. Like that all. Target code generator is having maybe 1 lakh lines of code. So if you add approximately if you add, let us assume 15 lakh lines of code. Whenever you say compile, everyone know compiler is a software. Everyone know compiler is a software. So when you say compile, which is a software, 15, right, this one, 15 lakhs of code. 15, right, everyone know 15 lakhs of lines of code, right, is running. Compilation is going on means 15 lakh lines of code is running. When you say 15 lakh lines of code is running, when you say that 15 lakh, right, 15 lakh lines of code will be present in main memory. This much code should be present in the main memory. Whichever is running, right, that should be there in the main memory. Remember, compiler is a software. Compilation is going on, means that software is running. Whenever you say that software is running, means that software should be there in the main memory. So try to understand it. Try to understand this particular story. Compilation is going on means compiler code is running. Compiler code is almost like 15 lakh lines of code. Right? 15 lakh lines of code should be there in the main memory. Let us assume that main memory is very small. Assume main memory is small memory. Assume that small memory. Main memory is very small memory. Let us assume. So 15 lakh lines of code may not present in the main memory at a time. It is not possible. If possible, if main memory is a bigger one, total compilation code should go to main memory. From there, compilation is going on. Everything is fine. Suppose main memory is small. You cannot send 15 lakh lines of code at a time to main memory. So what I mean to say is, if at all possibility there, compilation, let me write now. If at all more memory there, more memory available, you can do total compilation at a time. Total compilation, 15 lakh lines of code will go to main memory at a time. From there, your program is compiling. Right? Compilation. Let us assume that you have more memory. So total 15 lakh lines of code will go to main memory. From there, you can run at a time. This is called as single pass compiler. This is called single pass compiler. This is called single pass compiler. Suppose assume that, right? I done the compilation, right? More memory. Let us assume that less memory or less RAM, less memory, less main memory. Then total compilation cannot done at a time. So what will happen? First let us assume that 5 lakh lines of code will go to main memory, right? It will do 5 lakh lines of code, whatever can do, it will do. With that output, next 5 lakh lines of code. With that output, next 5 lakh lines of code means